We now know how a computer stores numbers. So you are probably asking yourself, well, that's great. I get that now. But how do they store words? Well, a few years ago, and by a few I mean a long time ago, but let's keep it to a few so I don't feel so old. So, a few years ago, a group of nerds got together and said, hey, how can we save text data using just numbers? Remember back in school when you'd write secret codes to your friends? And you'd do this thing where A equals 1, B equals 2, C equals 3, and we all thought we were so clever. No one could ever guess our clever plan. Well, those nerds in the room thought of this. Maybe because they thought the notes were about them. Maybe they were hoping they were about them. Whatever the reason, they came up with what is known as ASCII, or American Standard Character Information Interchange. It was a list of codes for letters that could be stored. Each code required a series of 8 bits to store. With 8 bits, we were afforded 256 combinations. Here we see an example of an ASCII chart. In this chart, we can see the first 127 combinations allow for letters, numbers, and special symbols. The remaining 127 became known as the extended set of characters, which could be used to draw things on the computer, since this was long before Windows was a thing. This is still in use today. If you're in Windows, go ahead and pause the video. Start up Microsoft Word and hold Alt while using your number pad to type in one of the combinations. It should print the related character. If there is an extended character you use a lot, you can use this technique to access it without having to go hunting in the menus. Grouping these bits into 8 characters became such a commonplace practice that we soon began calling them bytes. So whereas a 1 or a 0 is a bit, 8 of them together are known as a byte. A final couple notes. First, when you see the term kilobyte or kilobit, these do not refer to 1,000 bytes or 1,000 bits, but rather 1,024 bytes or bits. Remember, the computers work on base 2, not on base 10, so what is a round number in base 10 is not a round number in base 2. A kilobyte is 1,024 bytes, and a megabyte is 1,024 kilobytes. There are also designations for bit and byte in documentation. You will notice this when selecting a phone package or buying internet services for your home. When you look at these, notice that when a capital B is used, it is referring to bytes rather than bits. The way to remember this is that bytes are bigger.